Chemists use molar concentration to represent concentration in solutions a bunch. The definition of molarity is the moles of solute per liter of solution, right? So molarity, big M, equals moles over liters. And based on this name, it's liters of solution. So the way you do this, you figure out the mass you need, right? You can figure out the mass, turn that into moles, or either way. Then what you do is you add some water, dissolve it, and then top it up to exactly 1 liter to get for example, if you put 1 mole in there, you'd exactly 1 liter. If you had this guy and you added exactly 1 liter to this, the new volume would be greater than 1 liter because this guy's going to take up some space. So there's a correct way to make a 1 molar solution. Keep in mind the definition is moles per liter of solution. Calculate the molar concentration, so we're just going to use the equation now. So what is the molar concentration? Adding 50.4 grams to enough water to make 0.5 liters. So big M equals moles per liter. And how many moles do we have? 50.4 grams of copper sulfate times 159.6 grams equals 1 mole. And that equals, bad work by me. Here we go. It's 50.4 divided by 159.6 equals 0.316 moles of copper 2 sulfate. So 0.316 moles of copper 2 sulfate divided by the volume liters. Looks like 0.632 molar copper 2 sulfate. Nice. All right, so this is using the equation. So if you know 2 of the 3, you could solve for the missing one. In this case, we calculated molarity. This time, we're going to calculate... I think I skipped one. No? Weird. How much barium nitrate is required to make 0.750 mils of a solution? That is... All right, so now we have the liters, right, the volume. Not exactly, we have to get there. We have the molarity, and what are we solving for? How much, right? Much is grams, which we're going to get from moles. All right, so let's turn 750 milliliters into liters. So liters, milliliters, and 1,000 mils equals 1 liter. 750 liters. All right then, so now we can do this. Big M equals moles per liter so big M equals 0.500 molar. Moles is what I'm solving for, over 0.750 liters. Then I solve for moles, right, and multiply both sides by 0.75 times 0.5 is 0.375 moles of barium nitrate. And then I got to go from moles to grams, right? Just like we do. 61.4. I get 98.0 grams of barium nitrate necessary. So if I dissolve 98 grams of that into 75 mils of water, I can get what I need. Let's see. I could do this a different way, though. Let's do it this way. Let's do it like one big dimensional analysis. Let me go to the black pen. All right. So what are we starting with, right? Molarity is moles per liter. That's a ratio, right? Grams per mole is a ratio. So if we start here at 750 milliliters, I want to turn that from milliliters to liters. 1 liter is 1,000 milliliters. Now I'm in liters. What's the relationship between liters and moles? It's molarity. So 0.500 moles, equals a liter. So 0.500 moles equals 1 liter. And then 261.4 grams equals 1 mole. Mash that in, we'll get the same thing. So you can start doing these 2 different ways. You can kind of use the molar equation separately, solve for what you need, and then go ahead and do the conversions. Or we can start using it as part of our dimensional analysis. All right, so this guy says it's 0.500 molar in barium nitrate, right? 0.00 molar barium nitrate. This question says, what's the concentration of barium ions and nitrate ions? So to think about that, we have to think about when barium nitrate dissolves, right? This is kind of like our net ionic equation. When we take our ions and we separate them, I would get 1 barium-2 ion, and I would get 2 nitrate ions, right? So maybe you can see, I'll do a conversion here 1 second. You can see that you get 1 of these. So for every barium nitrate, how many nitrates do you get? 2, right? How many bariums for each barium? You get 1 barium. So the concentration of barium is, barium ion concentration, we use square brackets to say concentration, is the same, 0.00 molar barium. I already said that. Let's do the other one though. So let's say we had 0.500 moles per liter of barium nitrate, all right? What's the relationship between moles of barium nitrate and moles of nitrate? Well, there's 1 to 2. For every mole of barium nitrate, we have 2 moles of nitrate. So when I multiply this through, I get 1.0 molar nitrate ion, right? So what we recognize here is that, come on thing, because it's 1 to 1 for barium, the concentration will be the same as this concentration. Because it's 1 to 2 for nitrate, the concentration of nitrate will be double that of the original barium nitrate. So if we look at this guy then, what is the concentration of silver ion in silver nitrate? It's 1 to 1, so the concentration will be the same, right? It would also be 0.1 molar nitrate. What about this? If we dissolve this guy, he'd be 0.1 molar magnesium ion and 0.2 molar chloride ion. All right, so this is it seems like a small thing, but it's a really important thing. It all comes back down to these things are molecules and atoms, right? If I have 0.1 moles per liter of this thing, and this thing's made of 2 chlorides, then I must have 0.2 moles per liter of the other thing. Let's talk about dilution. So if I dilute something, I make it less concentrated, right? Like my Kool-Aid, add water to it. And when we do this, what we do, so let's say we have a solution here, right? It has a number of moles in it, or molecules. Right? When I dilute it, do I change the number of moles? I don't, right? So what's happening here? Big M equals moles per liter, right? Moles is not changing though, so moles equals big M times liters. That remains the same. Yeah, that's it. So if I have M1 and L1 for 2, and I compare that to a new concentration, M2, and I'll call it L2, then I'm going to change to V2. Here, the moles are equal. That means M1 times L1 equals M2 L2, right? Or as I wrote it down below there, I usually say M1 V1 equals M1 V1 equals M2 V2. This is my dilution equation that allows me to convert between these two things. That's the shortcut. But the important thing is that the number of moles don't change. The concentration changes, right, goes down because I add more volume. So let's do this 2 ways. So let's figure out the moles. Oh, I'm going to do this as millimoles. That'll be fun. So I have KCl. It's a 5 molar stock. And I take 100 milliliters of it. 100 milliliters of 5 moles per liter KCl. Right, okay. If I multiply these together, I get 500. Liters cancels liters, and I'm left with millimoles. Millimoles, KCl. But I want to get the new concentration, so I have to divide, right? Big M equals moles over liters. So I'm going to divide by the liters. So I took 100 milliliters and added 460 mils of water. So then the new volume is going to be 560 milliliters. So let's put this here, 560 milliliters. And let's calculate that. 500 divided by 560 is 0.893. And what happens here? Milli cancels milli, and I'm left in moles per liter again. So it's kind of a handy way to do. Millimoles are pretty cool. You could convert it to moles, right? You just have an extra step. You'd have to convert these guys from milliliters to liters. but you could do the same thing. Now let's try it this way. So M1V1 is M2V2. So what was the initial concentration? 5 molar. Initial volume was 100 milliliters. New concentration is what I'm solving, and we said the new volume is going to be that. So if I solve here, well, I'm going to get the same thing, aren't I? Lo and behold, 893 molar. And so doing the same thing here. The cool thing about this is these concentrations will stay the same. These units of volume can be anything. They just have to be the same. So you could have milliliters, liters, cubic centimeters, whatever it is, as long as the units are the same. All right, so this is dilution. Anytime you recognize that it's talking about dilution, M1V1 equals M2V2. Quick review of titration. All right, we've done this in lab. The important thing about titrations is that you are adding something that you know to something that you don't know, right? You don't know the analyte. You want to know it, so you add the titrant. So you add stuff in here, and at the equivalence point, some indicator changes color, right, like we've seen. And at the equivalence point, the moles of the two things are equal. So that's the important part. All right, we slowly add whatever it is, right? In this case, I'm adding base to an acid till it changes color, right? That's called the end point, all right, because my indicator changes color. And the indicator indicates the equivalence point, where the moles of the two things are equal. So we can use calculations for this now. So an unknown solution of HCl in here, is titrated with 0.100 molar sodium hydroxide. Okay, and what is the concentration of HCl if I use this much sodium hydroxide? What I know is at the equivalence point, moles of NaOH equals moles of HCl. So we want to know how many moles of NaOH we have, and let's do it this way. Milliliters of NaOH, right, times, what's the concentration? 0.100 molar NaOH. Millis, this is again, remember, is moles per liter, so liters are canceled. I'll be left with millimoles, so 0.105 millimoles of hydroxide, which equals the same amount, the same number of millimoles of HCl. So the concentration of HCl will be 0.105 millimoles divided by the volume of my unknown solution, right? It was 50 milliliters was in the flask. I added 11.05 milliliters of sodium hydroxide. So this divided by 50 milliliters, millis cancel and left with moles per liter. Concentration of HCl is going to be that's right, 0.0021 molar. All right, so this is a simple titration calculation. Moles of the two things are equal at the end point, the equivalence point. Whoa. Should we think about this? You should think about it. Go ahead and think about this and tell me, is the sample I got cocaine? And don't do drugs.